Welcome to the Vue Diagram tutorial. In this video, I will show you how to create a mind map diagram using the Syncfusion Vue Diagram component. I will also show you how to customize nodes and connectors in this layout, increase horizontal spacing, expand and collapse child nodes, and change the diagram's orientation. First, I open my existing Vue application where I've added the diagram component with basic properties like height and width. To learn more about integrating the diagram component into a Vue application, check the Getting Started video linked in the card above and in this video's description. Let me run this application using the command npm run dev. The diagram canvas is rendered. Next, I'm going to create a mind map diagram using the Syncfusion Diagram component's automatic layout algorithm. Mind mapping is a highly effective way to organize your thoughts without worrying about order and structure. Look at this example. It is a mind map representing concepts related to creativity and brainstorming. To create a similar layout, I will create a data source first by adding a file, data.js. Within it, define an array of objects named mind map data with the properties ID, label, parent ID, and branch. Each object in this array is rendered as a node. The ID property represents a unique identifier for each node. The value in the label property is displayed as the node's content. The parent ID property establishes the parent-child relationship between nodes. The branch property represents the position of the nodes in the layout. To bind the self-referential data to the component, in the app.vue file, import the mind map data from the data.js file. To bind this data to the diagram component, I need to pass it to the data manager constructor. So I import the data manager from the Syncfusion ej2 data package. The data manager can act as a gateway for local and remote data sources, using queries to interact with the data source. In the data function, define the data source settings property, create the data source property, and assign the data manager by passing the mind map data as a parameter. To identify the parent and child nodes, I map the ID property from the mind map data to the ID property and the parent ID property to the parent ID property. Now I assign this data source settings property to the diagram component's data source settings property. Now I want to render the mind map. From the Syncfusion ej2 Vue Diagrams package, I import the data binding and mind map modules. The data binding module generates diagrams from an external data source, while the mind map module arranges nodes around a central node. To inject these modules, in the export default scope, I use the provide option, pass diagram as the key, and set data binding and mind map as values. I save the file, and in the diagram canvas, you can see the nodes are rendered but not in the proper layout. To set the mind map layout, in the diagram component, I bind the layout property with a value. In the data function, I define the layout property with the type mind map. In the diagram canvas, you can see the nodes are now rendered in a mind map layout. The nodes and connectors are automatically generated based on the data items in the data source. However, notice that the nodes are empty. To display their contents from the data source, I need to set annotations for them. In the diagram component, bind the getNodeDefaults property with a callback method name. This method will be called whenever a node is created. In the data function, implement the getNodeDefaults method by receiving the node parameter. Within the method, set the node's annotations property with an array of objects. Within the object, define the content property and set the node data's label property. In the diagram canvas, you can see the nodes are now rendered with the annotations from the data source. To enhance the visual appeal of this layout, I will customize the height and width of the nodes, change their shapes, and apply background colors. In the getNodeDefaults method, I set the node height to 40 pixels and width to 110 pixels. I am planning to render a path node type with a custom style for the root node. To check whether a node is a root node from the data, I can use the branch property where I have set the value root. So, in the getNodeDefaults method, define a variable called branch and set the node data's branch property to it. Now, add an if condition to check whether the branch is root. And then change its default rectangle shape by setting the node's shape type to path. Then add the data property and assign the custom shape path value. Also, I customize the node's style by setting the fill color with a custom color and stroke width to 0. In the same condition, I check whether the node's branch is left or right to customize its shapes and colors. In the shape property, I check if the branch is not a root node and set its type to basic and shape to ellipse. This will set the ellipse shape only for the left and right nodes in the mind map. Using the same condition, I apply the style's fill property to set a different color for the left and right branches. In the else condition for other nodes, I add their style's fill property with a custom color and set the stroke width to 0. Since I have applied different background colors to all nodes, in the annotation property, I set its style's color property to white. Checking the diagram now, all the nodes are customized based on the provided details. All the annotations are white, the root node is rendered with a custom path shape, the right and left nodes are ellipse shaped, all other child nodes use the default rectangle shape, and the nodes are differentiated by the colors specified. Let me change the right side subnode's fill color with a different color. In the node's style property, in the fill property, add a condition to check whether the branch is equal to subright, then assign a new color. Now you can see the right side subnodes are in different colors. Now I will show you how to customize connectors. I am going to use the Bezier connector segment. First, in the diagram component, I add the getConnectorDefaults property and assign a callback method name that will be triggered when each connector is created. In the data function, I define this getConnectorDefaults method where I receive two arguments, connector to customize the connectors and diagram to access the component's built-in methods. To render a Bezier segment, set the connector type to Bezier and remove the target decorator by setting the connector's target decorator shape to none. You can see the nodes are connected using Bezier segments. Next, let me specify the ports for all the nodes to ensure that the connectors connect to nodes at a specific point. In the getNodeDefaults method, set the node's ports property with two ports with offset X and Y values. These will create ports in the middle of the right and left sides of the nodes. Next, I want to connect the nodes using these ports. First, I need to get the source and target nodes for each connector. In the getConnectorDefaults method, define a variable source node by calling the diagram's getObject method and passing the connector's source ID. Similarly, get the target node by passing the connector's target ID. In addition, define a variable branch and assign the target node data's branch property. I add an if condition to check whether the branch name is right or subright. Within this condition, I set the connector's source port ID property with the source node's second port ID by passing the index value 1 and accessing the ID property. Do the same for the target port ID and set the first port ID. Similarly, set the ports for the left and sub-left nodes. Notice that I have swapped the port indexes so that the nodes are connected opposite one another for left and sub-left nodes. I customize the connector style by setting a custom stroke width and the stroke color for both right and left nodes. Now you can see all the nodes are evenly connected at a specific point. Also, the connector's width and color are customized. Next, I will show you how to adjust the spacing between nodes horizontally. The default horizontal and vertical spacing between nodes is 30 pixels. To customize them, in the Layout property, set the horizontal spacing property to 50. You can also utilize the vertical spacing property to customize the spacing vertically if necessary. Checking now, the horizontal spacing between the nodes is customized based on the specified pixel values. Now I'll show you how to enable the expand and collapse icons in the nodes. In the getNodeDefaults method, I add the expand icon property and set its shape to -. I also add the collapse icon property and set it to +. See, clicking this icon collapses the child nodes and clicking the icon again expands them. By default, the mind map layout is displayed in a horizontal orientation. You can also render it vertically. To do so, in the Layout property, set the orientation property to vertical. Change the horizontal spacing to 40 so that the entire diagram will render within the diagram canvas and the window. Additionally, I need to swap the X and Y values so that ports will be connected properly. Checking the diagram now, the mind map is rendered vertically. In this video, I showed you how to create a mind map diagram using the Syncfusion Vue Diagram component. Additionally, I demonstrated how to customize nodes and connectors in the mind map layout, change the diagram's orientation, customize node spacing, and expand and collapse nodes. You can download the example used in this video from the GitHub link in the description below. I've also included a link where you can check if you're eligible for our community license, which gives you a free license key for our entire Vue suite. If you found this video useful, click the like button and subscribe to our channel to get notifications about new videos. Thanks for watching.